this Max tutorial, we'll build a pipeline that takes us from 2D feature tracking to 3D geometry. So the main thing in this tutorial is the screen to world conversion. You can think of it kind of as a connection between 2D normalized positions and GLSL objects. So we will use it to draw lines, but you can also use it to draw text or shapes or particle systems. This tutorial consists of 3 parts. In the first one, we will do a feature detection on an input video, which is this one here. In the second one, we will take those features and convert from screen space to world space. And in the third one, we will use those coordinates in world space and draw lines between them. I will start with a JIT world object as our rendering context. Here I have a JIT-P window so we can monitor what we're doing, and this is our input video. I will use the cv.jit package, which can be found in the package manager. So if you don't have it installed already, it will be under remote packages, but for me it's under installed. So cv.jit, and here I will be using the cv.jit.features object. Okay, then let's start with the first part, the feature detection. So the first thing I want to do, I want to downsample this texture. So first, let's take a quick peek. I think this is just full HD, so dimensions 1920 by 1080. So when I'm downsampling it, I want to keep the same aspect ratio. So let's create a texture for that. GL texture, then let's say dimension, so 16 by 9 times 232 times 10. Let's try 320 by 180. Then we need to say a depth 0, so this doesn't change. Then we need to go from a texture to a matrix. We can use jit.gl async read for that. And then the cv.jit.features object needs a black and white image, so we can get this by using the object jit.rgb to luma. Then finally we can use cv.jit.features, and let's say for now as our threshold something like 0.1 and distance, I don't know, can be 2 for now. Did we get an error? Okay, it's not relevant anymore here. Okay, then let's take a quick look into the output matrix. So as you can see, we're getting screen coordinates, but not normalized. We're getting the exact pixel coordinates, so I want to normalize this so that we get coordinates between 0 and 1. So in order to do this, we can use a jit gen. Let's call this one normalize. And in order to get them in a range between 0 and 1, we have to divide them by the dimension of the input texture. So we could do something like create a parameter, call this one in dimension 320 1080. And then we can just divide the input by those dimensions, and then the output will be in a range between 0 and 1. Hopefully, let's take a quick peek. Jit cell block. Yeah, this looks right. Now that we have these features, we can come to the second part, which is the conversion from screen space to world space. So the features that we detected are now in screen space, so normalized coordinates between 0 and 1. So these are flat 2D pixel coordinates. In the blob tracking tutorial I recently did, we just took them without any conversion and used them in a fragment shader implemented in jit.gl.pix to draw windows on screen. And this worked because this jit.gl.pix fragment shader also used 2D normalized coordinates. But now I want to use jit.gl.mesh, which is working in world space in order to draw lines. World space uses 3D coordinates in a virtual environment. So each time you're drawing something in 3D, like with a jit.gl grid shape or jit.gl.mesh or jit.gl text, you're going to be in world space. So if we create like a jit.gl grid shape, maybe also camera, position it a bit further away. When we now change the position, you can see that 0, 0 is in the center. And then here we're going into the minus direction, and here we're going in plus and minus for the y coordinates. And where we can see this one on screen also depends on our camera, because if I'm changing the camera position, this also moves. So these coordinates or these positions are a bit more complex than just having 0, 0 here, or 0, 0 down here and 1, 1 up here. So we need to find a way to convert between these normalized screen coordinates and our world coordinates. What we can use for this conversion is, among others, a jit.gl.camera. And maybe I will first create a jit.gl node, which we will use to draw the 3D objects, so our lines. Let's give this one the name lines, dimension for HD, depth 0 and capture 1, so we can see the output of this thing. Then I will create a camera, jit.gl camera. I will draw this camera to the node we just created. So at draw to lines. And now we can use the points that we get as an input with the message screen to world. And then as an output from the right outlet, we will get our screen to world position. The problem now is just that here we have a matrix, and here this expects just normal messages. So in order to get from the matrix to messages, we can use Jitter. Then we're getting the values out here. We prepend the screen to world message, plug this into the camera. And now we have normalized coordinates between 0 and 1, but I now have to put them in a range between 0 and half the screen size. So let's create another jit.gen, call this one just scale. I mean, I guess I could do everything inside this one, but doing it like that is a bit clearer to me. So we will multiply this and create another parameter, call this one, what do we call this one? Yeah, just screen size. Oh, sorry, screen size 1920 by 1080. And then we only need half of this. Okay, so again, here we're between 0 and 1, and here we're in screen size again. And because I'm downsampling here, and then I'm using the screen size of our resulting image again, I want to do this in 2 separate steps. Yeah, maybe let's call this one scale to world. Now let's maybe take a quick look if this worked. So yeah, we're getting something out of this one. This looks okay for now. And now we have to convert it back into a matrix again. So in order to do this, we can use, so as you can see, this message starts with screen to world. So we can use the root object screen to world. So now we'll just get the coordinates. Then in order to, oh sorry, I didn't mean to do that. In order to turn this into a matrix again, we can use a pack object with the message set cell. Then here we have the cell coordinates and then value 0, 0. So here we're getting x and y. So this will be the value for x and for y. And then, okay, sorry. First we need to bang this one. So trigger getting the list out of here, setting the list, and we're banging this. But there's still one thing missing. Because for our resulting matrix, we also need to know which cell coordinates we're writing these coordinates into. So in order to do this, we can just use the second output of the jit.iter, which is exactly the cell coordinate we're getting from the input. So this needs to go on the second inlet. I hope this isn't too confusing. Let's put it like this. Yeah. And then we can create our final matrix. Let's call this one world pause. Jit.cell block. Let's see what we're getting out of this one. Okay, this doesn't seem right because first we need to set the dimensions of the matrix, because what's coming out of here, so the matrix that's coming out of here is changing its dimensions for every frame because it's tracking points across frames. So if I'm looking at dimensions, you can see this changes all the time. What we can do to set the dimensions before we set all the points in here is we can use trigger list and then use the object jit matrix info, which just tells us the dimension of the matrix. And now jit cell block. Okay, this looks okay. Let's check this first before we move on to the next part. Okay, let's first use a jit.gl.mesh and draw some particles to see if this worked. So jit.gl.mesh at draw mode points at point mode circle depth, color can be just white, point size 15, and then we can also draw it to our lines node. So draw 2 lines. Then we can take this and use a jit bang to bang it for every frame. And we don't see anything because we have to connect this one here. Okay, this looks right, but to be sure, let's create a jit.gl pix and call this one mix. Oh no, T for title mix. And then we can use the original texture and combine it with what's coming in here. And you can see that if I'm changing the point size, it's easier to see that we're drawing points exactly on those raindrops here. Maybe we can also reduce the threshold a bit, so we're drawing more of them. But now you can see that these points are drawn exactly on top. Maybe let's make the input a bit darker so it's even easier to see. Okay, great, yeah. So this was part 2, the main thing, this screen to world conversion. And yeah, as I said, the cool thing about this is you can use it to draw a particle system, you can use it to draw text on screen, and it will always perfectly overlap the input. The only downside of this approach is really this conversion from matrix to messages and then back to matrix. So this is the real bottleneck here. So if, let's see how many points we have now. So if we have something like 100 points like we do now, or up to 2000, it shouldn't be a problem, but then it can really slow down your performance. So a better way to do this would maybe be to use a shader that can also directly access this screen to world conversion. But yeah, for the number of points that we're getting out of this system, this is totally fine. I'm still at 100 frames per second, so yeah. Okay, coming to the third and last part, which is drawing the lines. How am I going to do this? I will keep this here. And then create another jit.gl mesh, draw mode lines. What else do we need? Color. So we don't need this here. Color can stay white. We don't need this, but we need to draw it to lines. And if I'm just plugging this in here directly, nothing happens because it was the wrong inlet. Okay. You can see, I mean, you can use it if you like this aesthetic. But essentially, what this object is doing is it's taking, sorry, jit, what do I need? Jit cell block. So what this object is doing, it is taking, the first point is coming here, drawing a line to the second point. Then it's taking the third point, drawing a line to the fourth point. Then it takes the fifth point and drawing a line to the sixth point, and so on. But I want to randomly connect those lines, so I will quickly implement that. So there are more sophisticated ways to connect lines. Like you could check for each line, or for each point, you could check the distance to each other point. And then depending on how far they are apart, either draw a line or don't draw a line. So there's a great tutorial on this by Amazing Max Stuff. I will put it into the description. What I will do now will also look kind of cool, but it's a very crude approximation of the real thing. So the idea is to use a jit.multiplex, which kind of interleaves matrices. So it takes the first point from the first matrix that's coming in the first inlet and the first point of the matrix that's coming in here and connects them. Then it takes the second point of this matrix, second point of this, third point of this, third point of this, and so on. Which means that essentially the matrix that's coming into the first inlet will always be the first point of the line that we're drawing, and the matrix that's coming into the second inlet will always be the second point of the line that we're drawing. Then I will use a jit gen. Let's call this one, I don't know, connect lines. And what I want to do now is, as I said, so the first outlet is the first point of the line and the second outlet is the second point of the line. We can already connect this here. Then what I want to do is, so the first outlet will just be the first inlet. So for every point that's coming in, this will just be the starting point. And then for the second point, we will sample it at a random position. So we can say nearest and then bound mode clamp. And then just use a noise object. So this will just give us a random position. We can quickly take a look at this one. So maybe let's also connect this here and reduce the point size again. Yeah, not that interesting, I'd say. So what I would do now is I would check the distance between the random point and the actual input point. So in order to do this, we can say we're subtracting the actual point, or we're subtracting the random point from the actual point. Then we get a vector and then we can check the length of this vector. Then we can create a parameter, call this one threshold. Let's set this to, I don't know, 0.1 for now. And now we will check if the length, when the length is smaller than the threshold, this will be true. So it will put out a 1. And then we can use this to check, okay, if this is true. So if we have a distance that is small enough in order for the lines to connect, we can just connect them. So we can just use this input, or we can just use the random point we created. And if this is false, so if this distance is greater, then we can just use this point again. So if this is true, we will essentially draw a line between the input point and the random point. And if it's false, we will draw a line between the input point and the input point, which is the same point. So the line won't be visible because its length is essentially 0. Okay, then let's see if this worked. Okay. Nothing is happening, so let's maybe change the threshold. Now you can see if the threshold is very small, this is almost always false, so it will almost always do this one, and the larger the threshold, the more lines we're drawing. Yeah, I'm not happy yet with how this looks, so maybe in order to change this a bit, we can use a bloom effect. So a jit.gl pass at fx name bloom HQ. Then this also needs to be drawn to our lines node. And let's set the, what's it called, bloom amount 0.5. threshold. You know what? I will first check this before I go any further. So what do we need? White point, threshold, and I don't know, exposure bias maybe. Yeah, much better. So then I can say transform to arguments. And now I'm running out of space. Which is a problem I seem to run into very often. Okay, so maybe also change the point size here. Maybe also change the line width, something like 1.5. Yeah, that's much better. Yeah. And what you also can do here is, because we're just connecting random points, we can duplicate this matrix. Maybe with a jit concat, so trigger list. So what this essentially will do is it will take this input or this matrix, and so in the first inlet, and it will take the same matrix again in the second inlet. So we're kind of duplicating the whole thing, which means we'll get more random points to connect. And I mean, this is kind of a little hack in order to connect more points when you're doing it like that. I think there is no other real use case for duplicating it like that. So I'm doing it a bunch of times here. Okay. Yeah, and these are just the points, and these are the points drawn on top of the original image, and then you can play around with the threshold here. This is essentially what I wanted to show you. Again, I encourage you to try this with different jit.gl objects. You can also use it with jit.gl multiple and then draw windows on screen, or with jit.gl text to draw text next to those points. But yeah, I think this is a very neat way to get from screen space to world space. I hope you found this useful, and thank you for watching.